Welcome to this explainer. Today we're doing a massive analytical teardown. We're going to look at exactly how complex aerospace engineering translates into absolutely massive financial advantages for SpaceX. You know, as an engineer myself, the sheer mechanical audacity of landing a rocket, it literally blows my mind every single time I see it. But put on my investor hat, and I'm even more fascinated by the unit economics behind it all. How do you take an industry that's notorious for setting hundreds of millions of dollars on fire, I mean literally on fire, and turn it into a highly profitable, recurring revenue engine? So we're going to break down exactly how SpaceX makes its money, how rocket reusability totally transforms their profit margins, and what mega projects all this cash flow is actually funding.
Okay, let's dive right into this. Here's our roadmap for today. First, the engineering journey, then launch revenues, hardware specs, reusability math, the NASA contrast, and finally, future megaprojects.
Starting with Section 1, the engineering journey.
So before you can print money in the aerospace sector, you really have to survive a gauntlet of incredibly expensive failures. SpaceX was founded back in 2002, but taking massive financial losses on early disasters was basically a necessary engineering tax. You know, those first few launches were complete disasters, costing hundreds of millions of dollars. But early-stage space investors stuck with them, taking on astronomical financial risk for the potential of capturing a monopoly on cheap space access. And it paid off. By 2008, they became the first privately funded company to launch a rocket into orbit. In 2012, their Dragon spacecraft reached the International Space Station. And then, in 2015, they achieved the absolute holy grail, the first landing of an orbital rocket's first stage on land. So, those early disasters? They weren't just failures, they were basically paid research.
Moving on to Section 2, current launch revenues.
Okay, so the rockets actually work now, but how do they generate cash flow today to fund these massive operations? Well, the core of their current business model relies on three primary commercial customers: commercial telecommunication companies, NASA, and the US military. And the Dragon spacecraft's role is absolutely crucial here, specifically delivering vital crew and cargo to the ISS. Add in satellite deployment contracts for companies like SES and Orbcomm at highly competitive rates, and they're performing nearly 100 launches annually. That keeps their launch manifest totally full. If you want to launch a payload into space, the base rate for a Falcon 9 is $62 million. That can flex up by an extra $20 million depending on launch complexity. And if you need the really big one, the Falcon Heavy, the base rate is $90 million.
Let's hit Section 3, hardware specs.
Let's put our engineering hats back on for a second to look at the powerful hardware making these lucrative launches actually possible. This brilliantly illustrates the incredible leap in capability we're talking about. Take the workhorse Falcon 9, which carries up to 23 metric tons to low Earth orbit using 9 engines. Then look at the Falcon Heavy, which can carry a staggering 64 metric tons. That's nearly triple the payload. To pull that off, the Falcon Heavy basically straps 2 extra Falcon 9 cores to the side of a central one, giving it 27 total engines and an earth-shaking 5 million pounds of thrust at liftoff. And you know, the fundamental building block of all of this is the Merlin engine. Manufactured entirely in-house by SpaceX, each single engine emits between 9 and 14 kilonewtons. To put that into perspective, that's roughly 200,000 pounds of thrust per engine. Now, the sheer engineering challenge of having 27 of these firing in perfect unison and then selectively reigniting them to autonomously guide and land multiple booster stages simultaneously back on Earth, all while fighting unpredictable atmospheric drag, I mean, it's an absolute marvel of modern control systems.
All right, Section 4, the math of reusability. This is where we shift strictly into the investor mindset to analyze how saving this beautiful hardware completely transforms the company's unit economics. I really love this quote because it hits the nail on the head regarding the sheer absurdity of legacy expendable rockets. Throughout history, we launched rockets, threw them away in the ocean, and just built new ones. Imagine trying to buy a plane ticket if Boeing or Airbus had to build a brand new 747 for every single flight. A ticket to London would literally cost millions. By treating rockets like airplanes, the financial model completely flips upside down.
Let's actually break down the build cost of a Falcon 9. It costs around $50 million to build the whole rocket. But look at how that cost is distributed. The first stage, you know, that massive booster with the 9 Merlin engines, costs about $35 million to manufacture. That is a massive 70% of the total expense right there. The second stage accounts for about $15 million. So, if you throw the rocket away, you're just burning $50 million of hardware every single launch. But when you get it back, the main refurbishment costs, things like inspecting the airframe, replacing ablative heat shielding, and testing avionics, well, those are just a tiny fraction of the cost of building brand new.
Now, what's really interesting here is how that translates directly to profit.
If SpaceX charges a customer $62 million and it costs $50 million to build a disposable rocket, their profit is roughly $12 million. Hey, not bad, right? But if they reuse that $35 million first stage, their cost for the rocket plummets to around $20 million. Even when you factor in those refurbishment costs, the gross margins radically expand. Suddenly, the profit skyrockets from $12 million to roughly $42 million per launch. That's a real game changer.
And the financial stakes get even more extreme with the Falcon Heavy. Remember, the Falcon Heavy is basically 3 Falcon 9 cores strapped together. That means the first stage hardware costs alone are estimated to be around $105 million, plus another $15 million for the second stage. If they charge the customer the base rate of $90 million, but throw away the rocket, SpaceX takes a massive $30 million loss on every single launch. So, the absolute crucial point here is that reusability isn't just a fun perk for the Falcon Heavy, it's literally the absolute key to its viability. If they successfully land all 3 cores, that $30 million loss suddenly becomes an estimated $75 million profit.
To lock in those insane profit margins, SpaceX heavily relies on rapid turnaround times. If a rocket is successfully landed, the protocol immediately shifts to airport-like logistics, preparing for reflight potentially in under 24 hours. And crucially, this airport-like speed doesn't compromise hardware safety. Automated diagnostics and really rigorous standardized maintenance protocols are built directly into the rocket software. This ensures safety is verified instantaneously rather than relying on manual checks. Basically, the faster the hardware can safely clear maintenance protocols and get back on the launch pad, the faster they can recognize that launch revenue.
Section 5. The NASA Contrast.
Now, we have to acknowledge SpaceX wasn't the first to think of reusability. We really need to compare their modern success with historical attempts to understand their unique hardware design philosophy. NASA's famous Space Shuttle program ran from 1969 to 2011, and it was originally designed to lower the cost of space access. So why did the Space Shuttle program actually fail to reduce costs? Well, NASA's shuttle was technically reusable, sure, but its design philosophy relied on bespoke, incredibly fragile components like those delicate thermal tiles that required thousands of hours of manual labor to inspect and replace. It wasn't an airport turnaround, it was a bespoke, really expensive teardown every single time. SpaceX's design philosophy tackled this head-on by using durable, monolithic hardware designed for automated verification, completely crushing the operational costs that really crippled the shuttle program.
And finally, Section 6, Future Megaprojects. So what are these massive, reusability-driven profit margins ultimately going to fund? What are the future revenue streams looking like beyond simple cargo launches? $30 billion. That is SpaceX's projected revenue by 2025 for just one single, highly disruptive project, StarLink. StarLink is a space-based internet communication system, and it completely disrupts traditional ISPs because it totally eliminates the need to lay down and maintain thousands of miles of physical cable. If they can hit their target of 40 million subscribers for profitability, Starlink will generate vastly more revenue than SpaceX's entire current launch business combined. Think about that. This isn't just a little side project, this is the massive cash engine required to fund their ultimate goals.
And they are absolutely going to need that cash for their next big hardware leap, the Big Falcon rocket, or BFR. We're talking about a ship designed to reach mind-bending speeds of 18,000 miles per hour. Because ultimately, the main goals of SpaceX are to improve the cost and reliability of space access, develop a rapidly reusable launch system, and in the long term, achieve true interplanetary travel and space colonization. The specs for the BFR are just insane. It will carry double the payload of the Falcon Heavy, utilizing the exact same proven hardware concepts. But the vision here is what's truly amazing. As a parent of 2 myself, I'm endlessly fascinated by their Earthbound intercity travel concept. While it's currently still in the developmental and testing phase, imagine one day packing up the family, getting on a BFR, acting just like a commercial airline, and traveling to literally any city on Earth in 30 minutes, 10 times faster than a regular airplane, carrying 80 to 200 passengers per flight. Furthermore, future space tourism, like trips around the moon for around $58 million a seat, could eventually account for 10 to 20% of SpaceX's total revenue. Which leaves us with the ultimate question. They've fine-tuned the engineering. They've totally proven the unit economics of reusability. They're building the ultimate cash engine with Starlink. But will these massive hardware and financial leaps truly be enough to make humanity an interplanetary species and actually fund the colonization of Mars? It's a huge gamble, for sure, but betting against them hasn't exactly worked out well so far. Thanks so much for joining me on this explainer, and I really hope this deep dive leaves you seeing the rocket industry in a whole new light.